Activity 7. Exploring the algebraic development of the quadratic formula. This is part of Unit 4, Applications of Quadratic Relations. In the real world, applications involve quadratic relations that are challenging to work with, and most are impossible to factor. The rest of this activity leads you through a series of experiences to develop the quadratic formula, a tool that will find the roots of any quadratic equation in standard form. Deriving the quadratic formula by completing the square. We're going to look at a numerical example, y equals 7x squared plus 3x minus 5. And we'll also look at the formula development at the general form in standard form for a quadratic relationship. So we're going to walk through deriving the quadratic formula by completing the square for this numerical example, while at the same time following along with the formula development using the general form. So the first step that we need to do is to find the zeros of the quadratic relation. So where y is equal to 0. So we substitute 0 in for y. We've done this in both our numerical example and over here in our formula development. We then solve for x by completing the square. So we're going to complete the square here. We're going to factor the 7 out. We remove the 7, so we have x squared plus 3 over 7x. So we've removed 7 from the first two terms, just like we would when we're completing the square. So we're factoring out a. You can see that here. We factored out a from the first two terms. We factor it from x squared, and we factor it out of bx by dividing it by a. This step is finding out that third term to make a trinomial that is a perfect square. When we do that, we divide the coefficient here by 2 and then square it. Now, since we've added that, we also have to subtract it to make sure that we haven't added anything. So by adding it here and subtracting it, we've effectively added 0, not changing the value of the expression. Here it is without any numbers. So we factored out the a, and now what we've come up with is our third term of our trinomial that will create a perfect square trinomial. So we divided b divided by a by 2 and then squared it. Since we added this, we also have to take that away in order to make sure that the value of this statement remains the same. So now what we have is 7 that we factored out in the beginning, x squared plus 3 divided by 7x plus 3 divided by 2 times 7 squared minus 3 divided by 2 times 7 squared minus 5 equals 0. So we've just simplified these two terms here. We'll do the same here. So we've just simplified it so it looks a little neater. Notice again, this subtracting this would equal 0. They're the same. The same would go for these two. So here we're just completing the square. So we got here on the last slide. Our next step is to remove the second one. So to remove the subtraction that makes sure that the expression remains at the same value as it started out as. So we're removing that fourth term. so that now we have a trinomial here. When we remove it, we have to make sure that we multiply it by 7, because it was multiplying by 7 when it was inside these brackets. So when we remove it, we have to continue multiplying it by 7 to make sure that the expression's value doesn't change. We did the same over here. So here's our plus b divided by 2a squared. And then our b divided by 2a squared is here, times the a. We have to multiply it by the a because when this was inside this bracket, it was being multiplied by a. Now what we have is our factored form. So we've taken these big brackets and reduced it to x plus 3 divided by 2 over 7 squared. So our x squared becomes our x, and our 3 divided by 2 times 7 is here. And it's squared. So we factored this trinomial. Then we have negative 7 times 3 divided by 2 times 7 squared minus 5. Same thing here. So x plus b divided by 2a squared. This is our factored form of this trinomial. Our x squared becomes the x. The b divided by 2a squared becomes our b divided by 2a. Now we have 7 times x plus 3 divided by 2 times 7 squared, which is equal to 3 squared, which comes from this 3 being squared, 2 squared, there's the 2, and 7. Notice that we've lost this 7. That's because this 7 is squared. And so this 7 cancels out one of those squared 7s. So we're just left with 1. Then we still have our plus 5. It went from being negative 5 when we moved it to the other side of the equal sign. We did the same over here. So we moved this portion to the right-hand side of the equal sign. So this negative a becomes a positive a, and then we square b, 2, and a. This a cancels out that a, so we have 1a left, and the rest, the b squared and the 2 squared, remain. And we still have our minus c. Now what we're doing is we're trying to isolate x. Our first step is to get rid of the 7. So we divide the whole expression by 7. We do the same over here. This 7 corresponds to the a. So we divide the whole expression on both sides by a. The 7's disappear, except for on this side. And we have x plus 3 divided by 2 times 7 squared, which is equal to 3 squared divided by 2 squared, 7 squared. So this 7 makes the 7 that was already there 7 squared. But now we also have to add a divide by 7 for this 5. The same thing happens here. The a's disappear on the left side. This a becomes squared. And then c is divided by a. Now since we have squared on the left-hand side, we need to square root it to get rid of it. So we square root the whole side. We do the same on the other side. we perform the same on our formula development. So this gets rid of the square, and we can drop the brackets. Now we have x plus 3 divided by 2 times 7. And on the right side, we have plus or minus, because whatever is inside this square root could be a plus or negative, or positive or negative number. We see the same here. The square root has been dropped, along with the brackets and the square. And now what we have over here is this. Also notice that in this step, we've added some numbers to this term here, 5 over 7. We did that so that we can add them together. We were trying to find a common denominator. Notice in our next step, we have a common denominator. 2 squared, 7 squared, and 2 squared, 7 squared. That means we can add together the tops. We did the same over here. We're trying to find a common denominator, and we get it. Now we'll be able to write all of this over top of one denominator. Here's our one denominator. We still have the same on the left-hand side. So we're just simplifying things on the right-hand side, trying to make it as neat as possible. So we have the same over here, our common denominator. Next, we are going to subtract 3 divided by 2 times 7. We subtract it from this side, and it disappears. And we subtract the same on this side. So that looks like subtracting b divided by 2a. Now we just need to tidy things up on the left hand or on the right hand side. What we did here is we square rooted the bottom denominator. Square rooting squares will remove the squares. So now we have 2 times 7. And the top will remain. Notice that the denominators on both of these fractions are the same. Here's what we get. We did the same here. 2 squared becomes 2, a squared becomes a when we take away the square root. Now what we'll do is we'll add in or move this negative 3 to the left-hand side. We're adding it to this top numerator. We can do that because they have a common denominator. So move it to the front, so we have negative 3 plus or minus our square root of 3 squared plus 4 times 5 times 7. We do the same here. We take our negative b, place it here, and we plus or minus b squared minus 4ac. We were able to add or do this subtraction because the denominators are already the same. What we have here now is our quadratic formula. This is how we develop the quadratic formula so that we can identify the zeros or the roots of a quadratic expression.